All right, let's get started. How's everybody doing?
Pretty good.
Thank you. Somebody's there.
Oh yeah.
Oh
Well,
yeah.
hide away.
So somebody's supposed to remind me something.
Yeah, how something works.
Yeah.
Yeah, I feel like I was supposed to remind you, and I forgot what I was supposed to remind you.
I think you were supposed to remind me to take a control relay apart.
Yes, absolutely.
Let's let's do that. Whoops. I'm not sharing that. Can you see my screen? What do you see?
Yes, sir.
A really blurry control relay?
Extremely blurry.
Huh?
Extremely blurry. That's pretty good.
Oh yeah.
This is one of those Bolton 700 control relays. And looking at this thing, since you guys are all so astutely paying attention to what I'm saying, where's the coil on this thing? Where the two wires go to land on the coil?
Would it be? Is it the same one as our iceberg?
Your ice cube?
Yeah, ice cube.
It's the same. It's the exact same principle. Yeah, we're going to put voltage on the coil of this thing, and when we do that, it's going to change the state of all four sets of contacts. So let me ask you this: where are the four sets of contacts?
So one's gonna be normally open, one's gonna be normally closed, and then there's gonna be the actual coil, right?
Yes, but with the ice cube relay, you have basically three pins. You got a common, and you got normally open, normally closed. With these, you got in and out, right? So you have a coil that's going to change the state of contacts. Here's one set.
Okay.
Here's another set. Here's another set. Here's another set. Yesterday, I zoomed in on this thing to show you, like the difference. Like you could tell by looking at the rivets whether they were all the same or different.
Mm-hmm.
These ones are all the same. So I'm going to try to zoom in on the contacts themselves and see if you can make out whether they're normally open or normally closed. See it?
Yep.
What are they?
Oh, those are normally
closed.
Normally open.
Yeah, because you can see the little lines.
Okay.
It's right on this little tiny tab here. Okay. And so if you can't see it, you could just do a continuity check like we did yesterday, right? With your meter. So what I did yesterday with the meter was I put it on continuity, and then I put one lead here and another lead here, and then I manually push this in. So I just push that in, which simulates the coil being pulled in, right? And it changes the state of the contacts. So if I did that again, I'm not going to just to save time, but if I had my meter leads where these fingers are, and this is normally open, so I wouldn't be getting a tone. I'd push this in, then I'd get a tone. The cool thing about these is, well, there's a couple cool things. These big NEMA, last forever, built really well type relays and equipment is you can replace, if one of these sets of contacts gets burned up, you can replace them, right? Instead of replacing the whole thing like you would with that ice cube relay. The other thing is, I'm going to show you how to take these things apart, but let's say you wanted two normally open and two normally closed. I could take this thing apart, and you'll see this. I can take this set of contacts out, flip them around, put them back in, then they become normally closed. So before I do that, I want to show you guys where the coil is, and you'll be able to see it easier when I take it apart, but these two screws here are where the coil land. Remember, all a coil is just a piece of wire wrapped around and around, and it comes back out, right? So there's basically an in and an out. And then the coil itself is right here, and it's usually marked with the voltage for the coil. Okay, so this is where you would land your two coils, here and here. I'm gonna go ahead and start taking this thing apart.
Daddy?
So you can see the guts.
Ours doesn't really come apart, does it?
No, it sure doesn't.
What's the red tab on the bottom for?
On yours or mine?
Mine.
That's for putting it
Pulling
on.
it off. Pulling it off the den rail, right?
Yeah, so here's what you're talking about. There's this little thing is like, it's kind of like a spring. So if you pull that thing down, it will snap onto this stuff called din rail. And on your trainer, I've got it just screwed onto the backboard.
Yeah.
But you could mount it to din rail the same way that like your red and black and gray and your fuse holders, that little piece of aluminum that all snaps into is called din rail.
And correct me if I'm wrong, but you can take the clear plastic off the relays, right, and clean the contacts on them, right?
I'm sure it depends on the manufacturer.
Well, sometimes they'll snap and break into pieces, but some of them, the Allen Bradley, actually, the little contacts will clean up fairly well on the little tiny relays that we have.
Mm-hmm. All right, I'm gonna take this guy off. You can see this. I thought that came out next, but no, it does not. Oh, I remember. Okay, so let's say I wanted to change one of these contacts out. Meow. So all I did was take these two little screws out that hold the wire in place when you wire them in there, and then this thing will just pull out. And normally open, if I want to change it to normally closed, go like this. Bloop, put it back in, screw it on. So you can see how they operate though, that when I push this red tab down, like the coil's getting pulled in, these things also pull in. And one side of it, like imagine these are the contacts themselves, right? When this gets pulled in, you can see it making, I don't know if you can see that or not, but inside there, when this thing pushes up and down, it makes and breaks those contacts the same way a push button would, right? All it is making and breaking. So one way it would be normally open, the other way it would be normally closed when that thing pulls in the one direction. So I'll go ahead and change this out so we'd have this one set of normally closed. and you can see the difference also in that symbol at the top. Let me zoom in so you can see normally closed and normally open right next to each other. See the difference
Yeah.
between the two symbols there and there. Come on. So that's what you would do if you wanted to change the contacts. Replace the contacts. For my next trick, I will show you the coil. Here's the coil underneath all that. Pretty jacked up. I'm not going to take this thing apart any further, but you can see here's your coil, right? It's just going to go in there and like a little in one side and out the other, wrapped in a circle, and then you have this iron core that when that coil gets energized, it creates a magnetic field and goes sits on the spring. Right, so when that thing gets energized, it pulls that in. Make sense?
Yep.
Changes the state of the contacts. Cool? All right.
It's just a big version of the little ones that we have.
Exact same principle. But yeah, big and heavy duty. That's what NEMA is. It's my favorite. We just farted.
Not me.
All right, so that being said, what is this thing?
What is it?
What is it?
It's a contactor. It's got a set of overloads that you can reset on the bottom.
Yeah, but it's not a contactor. What is it?
Looks like a bigger version of the same thing.
Yeah, it's the exact same thing, but it has overloads.
Okay.
So you guys did this Lab 5B last time. I'm going to show you the next one. All it is the same thing. We're going to use a control relay, but we're going to use a motor starter. And your motor starter obviously looks different than this. But these are where the overloads are. They have a little heater inside of them that will open up the circuit if the motor gets too hot. All right. And associated with those is this normally closed set of contacts. Okay. So these will open up if those heaters get too hot. Okay. So it's the same thing, same exact thing except we have these overloads in there. All right, here's your coil. All we're trying to do is make and break between these three sets of contacts. 1, 2, 3. So this is a three-phase motor starter. And then your coil is right here. So let me show you. Looks awful familiar, doesn't it?
Yeah. Looks like the same exact thing, but MS instead of CR.
So what does MS stand for?
Probably motor starter, since that's what you said it was going to be.
Yep. So where on your trainer is the motor starter?
It's probably just going to be one of the relays wired different.
I don't think he was here for the one where you were saying he used the
Oh, the
the
little guy?
the one on the breadboard.
Yeah, it's just the little one that's on the breadboard.
Yeah,
I'm just going to show you guys real quick and then I'll let you tackle it. But you're going to have a coil, right? So look at motor starter 1. Don't forget your wire numbers. The first thing I'm doing here is I'm going to put wire numbers on. Well, let's just do it together. So what number is this over here?
1.
1. What number is to the right of the motor starter coil?
2.
2. And this is also a 2. I'll get back to that in a second. So this would be 3 and 4. There's no pilot light here. All we're doing is getting the motor starter to turn on and off. You've done it the same way, but the only difference with these is there's an overload. So real quick, I'll show you on a NEMA motor starter. The same if you had an IEC, a small one. But right for us, we're just simulating a motor starter on your trainer. But you're going to hit the coil, right? The MS1 coil on your relay. You don't have an overload, but if in real life you did, one side of the coil is where you would run to. The other side, like on this one, already has a pre-wired jumper, right? So
Okay.
this one, I think, I don't remember, it probably goes right there. So it's got a little pre-wired jumper going to the normally closed motor starter. Then this one usually has a pre-wired jumper that goes back to one of these. So these are auxiliary contacts that slap onto the side of these things. Okay, so these would be my holding contacts or however I want to run them. But that's where this wire would normally go to. Let's see. So how these things operate is that when this coil gets pulled in and it goes from off to on, it also pulls up these little tabs right here, which actuate these contacts and open and close them. So that's the only difference between a motor starter and your setup. You're going to use your little ice cube breadboard relay for the motor starter coil, and then a set of normally open contacts associated with them. So all this lab is telling you to do is a basic stop-start station for a motor starter with holding contacts. Okay. And I'm going to let you guys try to tackle that without showing you how to do it.
Gotcha. All that's supposed to happen is the motor's supposed to turn on.
No, we're not even hooking it up to the motor yet.
Okay.
So that smaller wire that you gave us on the larger reel, is that used for stabbing in? Will that stab directly into the breadboard?
Yeah, and that's why I gave it to you.
Okay.
So are we unhooking our ice cube relays then?
Your motor starter is this little guy that stabs into your breadboard.
I put that in my breadboard, but I was just wondering because I see there's two motor starters on here. Well, I guess they're both ones, but those are two different motor starters, correct?
Which part are you talking about? MS1s?
Yeah.
There's one. Just
That's
different.
all the same motor starter, right? This is just the coil,
Oh, okay.
and this is normally open contacts.
Oh, okay. I thought it was two different ones. I'm sorry. I got you.
So what should we do to make sure it's right?
Well, when you energize it, what happens, or what should happen?
Well, I don't know exactly what should happen. I know what's happening. It's staying open.
What do you mean it's staying open?
Normally, sorry, I meant to say staying closed. When I press the button, the normally open contacts stay closed until I press the stop button.
That's perfect. That's all you need to do.
And then, is there a reason why when I press the stop button, my green light flashes? Nothing's connected to my green light.
I do not know. Can you show me? Do you have a camera?
Yeah. Can you see everything?
Yeah. Let me see that light flash.
So I press the button, it's normal. I press the stop, and it's just faint. It's like if there's a little spike. Can you see it?
Do you have anything hooked up to the green light at all?
Nothing. My green light's my green wire up here.
I don't know. You might be catching some kind of ghost voltage or like transient voltage from that coil energizing, de-energizing.
Yeah.
Remember, I don't know if they taught you in 133, but when you de-energize an inductor, there can be a massive voltage spike. So
Okay.
you might just be getting some kind of transient doodad, but
Yeah, that makes sense then.
I wouldn't worry about it.
My meter doesn't read it in the green lead.
Okay, I think I got mine working. So when I push the green start button, it doesn't do nothing though. So I don't know if it's right. When I push my stop button, it closes the contact. When I push the green start button, it doesn't do anything.
Can you show me?
Yeah, I can show you. Here. Let me know when you can see it. Oh, shoot. Can you see it?
No, I can't see anything yet. Your camera's turned off.
Oh, shoot. I'm sorry. You see it now?
Yeah. I can't really tell what's going on though. Just
Okay,
take that first rung and look at wire number 1. Is it going from the power supply to the stop?
right here.
Wire number 3's.
Wire number 3 is going here.
I know, but you need to walk through each of those components and say, okay, the other side of my stop, do I have a wire number 3? Where is it going? Is it going to the start push button?
Yeah, it is.
Is it going to normally open MS1?
Normally 3? Yeah.
So it's going down to the red.
Normally open. Yep, it's going down to normally open. That's wire number 3. Wire number 4 from the coil to the push button. Then I got the on the other side, the number 4 going from the normally open to the start button. On the other side. And then wire number 4 going from the push button to the coil. I got my on the other side for my number 2. Hold on, let me go whoop some ass real quick. Hold on. All right, I'm back. So I don't even know where I was at. I guess my number 4 is going to my coil. And on the other side, for my number 2, I got my coil going up to my negative. So when I push it, the stop button, it closes. But shouldn't the start button do that?
I'm gonna try to expand your video here.
Would it help if I shorten these wires and like so it'd be easier to see?
Well, do you
Probably.
have, okay, so describe to me what happens when you push the start button.
Nothing at all. Nothing at all. It's when I push the stop button. When
That's
I push,
the relay clicks when you push the stop button.
yes.
Okay, I don't feel like you, I feel like you're getting 24 volts at the coil right off the get-go. Do me a favor, pull the fuse out. Pull the little fuse holder out. Just pop that little door open. Did it unclick the relay?
No. The relay doesn't stay clicked. So it releases when I let it go. That's why I think something is wired wrong.
All right.
So my start button is wired. I mean, all this is wired, right? So this is going to. Oh yeah, that's going to my. So I got power going to my stop button. My stop button's going to my. My stop button's going to my
Oh,
start
crap.
button.
Hey, I forgot one very important thing. And I hope I didn't just smoke all of your relays, but
Resistor.
yeah, so that's a 12 volt coil. Probably didn't hurt anything to put 24 on it. But we also need to put a resistor in there as a voltage divider. So we can put closer to 12 volts on the coil. So what you guys are going to need in your kit, there's these little things, these little bands of resistors. One of them says 220 on it. It's a 220 ohm resistor. Put that in series with your coil whenever you hook it up. I'm sorry, I forgot that.
When you look at mine, mine's actually 24 volts.
Well, you're cheating.
Yes, I am. Is that bad? That's the only one I could find.
My coil is making its own little heat. It's got some steam in the case.
That's magic.
Yeah. But I could boil a little bit of water. It's getting so warm.
You said which resistor? Are these all the same? These
What
are
did
all
you
the
say,
same.
Garrett?
I said mine is really warm and there's a bunch of moisture on the inside that looks all steamy.
Okay, is it still energized?
Well, I unplugged it.
Okay, good.
Yeah,
I
mine's
let
warm
that thing
too.
cool off a little bit. Try it with resistor in there and see if it still works. If we just
Yeah.
smoked all of our little ice cube relays, we'll have to use the ones that are mounted to the board for the motor start.
No, mine still works how it's supposed to.
Okay. It might not for long, but that's okay.
We're supposed to hook the iceberg relays up too, or the ice cube relays too. I'm confused. I think I got lost.
All
Are
we're
we
doing is
trying-
hooking up this coil, this motor starter. That's all we're doing. We're going to take 24 volts to it. This knocks it down to 12 volts, right? And
Oh shit, these aren't all the same resistors, are they?
No.
No, there's you don't have to remember color code. The little labels, they're on the yellow strip.
Oh shit. Okay, I see that. Which resistors you say we're putting in there? I'm sorry, I didn't.
220.
Which one? I'm sorry, I can't hear. The
220.
220? Okay, I got you. I got it. All right.
Everybody else take off.
I'm still here.
Okay. I can't see anymore, I guess. Okay. Where did you end up landing the proc switch at? Did we have to land all 3 wires? Because
I'm not sure what you mean.
Yeah. Can you see my screen? Can you see my
now.
timer?
Hold on 1 second. Okay. Because all I can see is the blue and the brown.
Yeah, this is all 3 of them.
Okay, so they each have their individual terminal strip.
Yeah, you got 24 volts, a negative, and then a normally open lead.
Okay.
With the negative as well.
Is that a feedback switch?
Hmm?
Is that a feedback?
It's
Or is
just,
that
it's
just for
like
the LED?
What? It's an inductive proc switch. So it takes 24 volts to power it, and
To close it.
it will open contact. I'm pretty sure it opens contacts when something is close to it.
That's
Something metallic.
Dependent on if it's a PNP or NPN, right?
Yeah.
Okay. All right. Sorry, I'm just trying to get caught up.
Hey, Justin. Did you get it figured out yet?
No, but I'm working. I'm gonna try to get it.
You got a wire going from your red over to your stop push button, right?
Hold on. Let me start back where you're at. You said a red going from the stop to start. Yeah, my number 3 is going from stop to start. So I'm good there. I'm gonna start over. Let me start over. Make sure I do this right. So 3. Yeah, relabel. I know what I'm. Three. I know when we were putting in that control panel, that or a circuit breaker panel, I learned the importance of labeling. If he didn't label before he disconnected the fuse box and spent half his time trying to figure out what went where, I knew that was an important lesson.
Yeah.
I said, I see why Zach said we need to label now, because you don't know what the fuck goes where, do you? He said, nah, I should have took the time to label. I was just trying to get it done. I said, I see why now. I see why he said label everything. I get it. Because you are lost in the sauce, my man. I when I went back and rewatched the video, I know you guys were saying, why was he drilling through the concrete to put the ground rod there? That's where the owner wanted it, because he wanted to put it off in the dirt to the side, but the owner wanted it drilled right through the concrete right there. That's where he wanted it. And he actually wanted it underneath the little roof, but that's an 8-foot rod and it wouldn't fit. So he was trying to tell us to cut the ground rod in half, but my buddy wouldn't do that. He said, no, they're supposed to be 8 feet for a reason. So he said, I'm not going to cut it in half. I'm not going to be responsible for it if anything messes up. So he wouldn't do it. So, the guy just told us to bring it out a little bit so it'll fit. But he wanted us initially to cut that rod in half.
In certain places, by code, when the inspector comes out, if you put a ground rod in, they have a resistance that it has to meet. So you have to have so much resistance to ground, and it has to be so low for that in order to have a certain amount of continuity to ground like that. And we've had to rent that meter before, but that's like a couple $1,000 meter that tests that resistance to ground.
Yeah.
And if it's not 8 feet, you don't have enough resistance, you got to drive a second grounding rod.
Yeah, I've heard of that. But yeah, he wouldn't cut it. Dude wanted us to cut it in half. He said, hell no, I won't do that. He said, if you do that, he said, I won't do that. He said, whatever you do when I leave, that's on you. He said, I'm driving this grounding rod right here. So he said, if it can't fit underneath, then he wanted to drive it in the dirt, but the guy didn't want it driven in the dirt. I don't know why. I don't know what difference it would have made, really, but no. I don't know why he wanted it in that location, but that's where he was fixed on it being right there by the meter box. So, all right, so I got my number 1 hooked up. Let's see. On my number 3. So number 3 has to go from the start to the normally open.
All right. Do you have? So I got 24 going to the stop. The other side of stop going to the start. Right.
Yep.
Here.
I got that.
Now the other side of the start
Right.
needs to go to
The normally open.
the coil.
Oh, it goes to the coil. I thought this.
So this is wire number 3. Are you still on wire number 3? So you also
Yeah.
need wire number 3 then to go to normally open. That's right.
Right. I was sure about to say, hold on. I thought that was a normally open. All right. So yeah, I'm picking up what you're putting down. So I got that. Shorten this wire so it'll be easier to see though. At least I had that part right. I knew that part was right. Okay. All right. Now it looks like I have a number 4 going from the normally open to the other side of the start, which I had. Let's see.
Is this what yours looks like?
Not at all. Where? Hold on. Okay. So you got. I see. The other.
Forget about the red and the black wires. Don't even worry about those. It's something else that I did.
Oh, okay.
So normally open on this, if you've got yours plugged in all the way at the bottom, is going to be, mine's plugged in all the way at the bottom. So normally the common is 28 and normally open is 30. So this is my wire number 3. It's on the same potential as the one coming from the stop push button and the start. It's all in the same row.
Oh, see, I didn't do that. I put mine on the other contact for the same side of the push button. So okay, you got that there. But what I'm curious is okay, you're coming around to the other side of the push button. And you're on the common? You're on the common, right?
It doesn't matter which side of the relay.
Okay. Okay.
There's 2 sets of contacts there.
Yeah, see, I'm coming on the same side, and I put mine on the normally open.
So you did this.
Yeah.
That's fine. Doesn't matter.
Okay.
Using the common, you can reverse the common and the normally open, and they'll work the same way. All it is an open set of contacts that closes.
Okay. So from number 4, then I would come from the common, which is number for me
28.
20. Mine's is 20 because I don't have it all the way at the bottom.
Okay.
So I'm at number 20. And then I'm going up to the other side of the push button, correct? So I got that. All right. Now I need to go from the push button, to one side of the coil.
To the coil.
Huh?
To the coil.
Yeah. And I go from the other side of the coil to the negative, right?
Yep.
That's what I was thinking.
But just remember to put your resistor in there.
Yeah, what does the negative side get hooked to? I put the resistor in there. Oh shit, where's my resistor go? Oh, no. I'm not that much fun. Because I see the resistor, but I knew to hook the one side in with the coil. The other side, I just really wasn't quite sure. Shoot, man. Because I knew I had to go to negative some kind of way. Or is it not going to negative? Oh, okay. I had it. Hold on. You have the other side hooked to your push button?
Other
Is
side.
that what I'm seeing? Of the resistor. Is that what I'm seeing?
Second. The other side of what?
That resistor. Is that other side of the resistor hooked to the push button? I can't really tell because I see a blur right there. No, you got a jumper wire. Yeah, is that on the same one as the other side of your resistor?
This is wire number 4.
Right.
So it's going from 4, so the other side of the push button, through this resistor to the
Right.
coil.
Okay. Right, I got you. Mine's close enough. I can just put the resistor in with the push button. Mine's close enough to the push button.
I don't know if that's any better.
Well, no, I'm not saying it's better, but it'd be the same thing, though, right?
Huh?
I said it's no. I'm not saying it's better, but it's the same thing.
What?
I got my resistor just hooked into the other contact of the push button.
Yeah, that's fine as long as voltage goes through the resistor and then to the coil.
I got my negative. Let's see. So a resistor would be my number 4 then. Yeah, the resistor is my number 4.
Yeah. So on your ladder diagram, your resistor should be right here.
Right. That's what I got there. And the other side of the coil.
Is just the black negative.
Yeah, I got that. I think I might have it now, but I don't know. Let me see. 2 and 2. 2 up here. So when I push the stop button, now that's making my relay close, but it doesn't. Okay, but it's not staying. It's supposed to stay, right?
You're hitting the stop button.
The start. The stop button doesn't do anything.
Push the stop button and then hit the start.
Okay, I got you.
Okay, so
Okay,
you're hitting the
all right.
start, but it's not sealing in.
No, it's not.
Okay, so do you have... You need to look at these 2 wires here. These are your seal-ins.
Okay. And those would be number 3s, right? Nope, those would be number.
This is a 3,
Yeah.
and this is a 3, right? See how they're connected up here? These 2 are 3s.
Okay.
The other 2 are 4s.
All right.
Can you tell what you did wrong?
Yeah. Yep, I got it.
Zach, I got mine done. It looks god awful ugly, so I can show it to you real quick, and then I'm gonna clean it up.
Okay.
Yeah, I warned you. It looks ugly as hell. So here we go.
Go ahead.
Let me figure out how to do this. All right. Okay, so energized. If you can see it.
Cool.
Yeah, I'm gonna clean it all up. This looks like hell. So
That's fine.
yep.
Clean her up how you like it. And then the next time we'll run those motor starter, the MS1, these. We'll run those to the motor. So your motor starts at the same time like mine is.
Hell yeah.
Yeah, I seen what I did wrong. I just didn't run. I didn't run my number 3 wire all the way to my other side of my push button again. For the normally open, I didn't run it back.
Seal in contacts.
Yeah, I didn't do that. That was the only thing I was missing. So I got it. Probably need to take a look now, right? So you need to take a look now?
Is it working now?
Yeah, it's working.
Oh yeah. Hey Zach, do you know where I would get a desolderer locally?
The only place I could think of would be maybe Radio Shack, but no, I don't know who would carry that. Best bet would be
All right.
online. And I don't even know if Radio Shack is open anymore.
Nah, they don't. That's a thing of the past now, bud.
They've extinct.
Yeah, they've been gone for a minute now. Sadly, though, that's where you could have got everything, you know.
So is there any reason when I hook the motor up and I briefly press the button that it doesn't stay on?
Did you hook your motor up over here like I did?
Well, I hooked it up. I don't know if I did it just like you did.
Well, all you're doing is running the motor through the other set of normally open contacts. So here's my motor. I'm coming in from the red terminal strip. What?
I can't see yours.
You can't see it?
Yeah, I don't know. I'm just getting like your camera shut off. I don't know. Maybe it's something I'm doing.
Yeah, because I can see his just fine.
Yeah, maybe you have to refresh or like zoom out or something.
Hold on.
You might. Did you pin my video?
There.
You might have to.
I got
it. Okay.
So what do you have running?
These are my motor. I'm coming from the red terminal strip to get 24 volts.
Okay.
And when the coil gets energized, this goes to the motor, turns it on.
Okay.
So if you're pressing the button and letting go and the motor turns off, then you don't have your seal in right, which are these.
Okay. It's because I just plugged in. I got you. You're right. I don't have it right. I essentially just had the motor hooked up to the button is what happened.
Oh, okay.
Hey, Zach, we're done with the lab. We can get up out of here.
Yes, sir.
All right.
I got to get going pretty quick. I got a meeting at 11.
Okay.
So.
Okay. Busy man. All right. Well, I'll see you tomorrow then, all right?
All righty.
Sounds good. See you guys later.
See you.
So, Zach, for my labs that you haven't seen, do you want me to just record them and put them all in that folder? Since
Yeah,
I've
that'd
gone?
be fine.
All right.
All right, you guys all good for today?
Yeah, I'm good.
Yeah, I about got my board set up completely.
Okay.
So I'll start knocking my labs out after this.
All right. Do you know how to record them and put them on the shared drive, Nick?
Yeah, I'll just do it with my cell phone. Probably be easier than trying to manipulate the laptop. Although I have a webcam coming so that it's easier to move it around and get a better picture because I don't setting my laptop up to record, like to get it all is kind of hard. So
Yeah, that's fine. And using your phone is easy enough anyway. You can also get a Google Drive app on your phone. So it'd be a pretty easy way for you to upload it. But
okay.
anyway.
All right. I appreciate your time.
All right, you guys. Have a good rest of your day.
You too.